They give z is in this expression, but this is not a standardized format. And then later on, the question said that z, the real part of z is 1. Then mean if we separate z is how many plus how many I here, then this real part is equal to 1. This is our strategy. So for z here, we have to use what we have learned. It seems like rationalize to make sure it is in the standard format, real part and imaginary part separated. Then we can use the information here, the real part is equal to 1. Then maybe we can able to solve A afterward. First, we can't accept the denominator exists I here. That's why we try to do something to make square term only below the fraction line. And if you multiply the same thing, it doesn't work because it will give you I still in the middle. So when we find something plus something, we are going to multiply something minus something. Of course, we have to do the same for fraction, avoid changing the values. Then we just follow our decision here, and we just focus in denominator first. For the denominator, we have something square minus something square from the identity. The first item is 1, the second item is AI. So we have 1 minus a square, I square. And beware that the nature of I square will be replaced by negative 1. So minus a square times I square will become plus a square below. So we have 1 plus a square below. I think this is good enough because no more I below, and then I can separate the fraction to real part and imaginary part later on. So the next step is to expand this item. So we choose one bracket to remove it. Maybe I choose the first one. If I remove it, I will have 3 times something, positive I times something, which should be both 1 minus ai. Follow our decision, 3 minus 3a times of I, and then plus I minus ai square. Again, I square here will be replaced by negative 1. So the sign will be changed and then become plus a here. Afterward, the most important mission is to separate the real part and imaginary part. Don't forget it. So with I, we put it at the back. Without I, the real part, we put it in the front. Then it will become 3 plus a minus 3ai plus I, and then over 1 plus a square. We are going to separate it 3 plus a over 1 plus a square, together with another part, negative 3ai plus I over 1 plus a square. I suggest your negative don't write here, otherwise this sign will be affected and usually you will forget it. But anyway, just now what we said, this is involving I. So to be more obvious, I can rewrite in this way. Is I extract I outside, so we have negative 3a and positive 1 here. So therefore, what they want to say is this equal to 1. Then we can draw the conclusion. Since 3 plus a over 1 plus a square equal to 1, 3 plus a equal to 1 plus a square. Again, we have an equation, the power up to 2, so it's quadratic, and then we use the standard procedure. A square minus a, and then minus 2 here. Put everything to right hand side equal to 0. Then we can use our calculator formula 1, or you can factorize it if you want. A minus 2 times a plus 1. Therefore, the answer is not only one answer, but a equal to 2 or another possibility, a equal to negative 1. The answer is D here.